Hey everyone, welcome to example number 2 on graphing radical equations. So in this one we're going to graph y equals the square root of x plus 2. Now this looks very similar to the first example. The only difference is this number. We're actually just shifting the square root of x function up 2 units. So there's a shift up, okay, of 2 units. That means every y value is affected. Every y value is shifting up 2 units. Recall from the previous example, I'm only going to put numbers in for x that work in the domain. So I'm going to start with 0, I'm going to use 1, I'm going to use 4, and I'm going to use 9. Now I can use any number greater than 0, but I want to pick numbers that are perfect squares to make my simplification easier and easier to plot my points. So again, we're thinking of a shift up of 2 units. So if we plug in the square root of 0 plus 2, that's just going to equal 0 plus 2, which is 2. So you still have to plug in and simplify. So our first point we're going to do is 0, 2. So I go over, 0 over and 1, 2 up, and notice from the original function, this point's 2 units up. So the original square root of x is 0, 0, 1, 1, 4, 2, and 9, 3, right? Those are the original. It's just a shift up of 2 units. And so I continue along that. I keep plugging in numbers. The square root of 1 plus 2 is, well, the square root of 1 is 1 plus 2, that's 3. And I can continue on doing this. So then I get 1 over and 3 up. 1 over 3 up. So right here. Okay. If I plug in 4, I get square root of 4 plus 2. Okay, and that's going to be 2 plus 2. Which is 4, so 4, 4 I plug in. So 4 over, 4 up, and the last one is going to be square root of 9, square root of 9 plus 2, which is 5, right? 3 plus 2. So I go 9 over 5 up, and notice how 1, 2, 1, 2, and there's my graph. Now, if I wanted the domain, okay, the domain, the x's are not going to change here. I've only shifted this graph up. So the domain is not going to change from the parent function. So the domain is x is greater than or equal to 0. You can also put that as 0 to infinity. That's interval notation, either way. Here's where it changes. The range is going to change from the parent function because I have shifted the graph up 2 units. My lowest y value now is not 0, it is right there. Okay, at that vertex. So y has to be greater than or equal to 2. And you can write that in interval notation. Okay, you can have that as 2, okay, to infinity. And there you go, there's the domain and range. You can also graph this. If I went back to my y equals here, I already have the square root of function in, so square root of x, okay, plus 2. And I can verify that graphically. There's the parent function, and then there's my function, so they look identical. So let's move on. This next example is a little bit more tricky because we're inside parentheses here, inside. So when we're inside, we're affecting the x value. This is going to move all our x values right 3 units. And you'll see that from the activity that you guys are going to use on GeoGebra. Okay, so right 3 units. Now I want to be real careful what I pick for x here. I can pick anything that's in the domain. Okay. However, I don't want to plug in 0 here because if I plugged in 0, I would have the square root of 0 minus 3, which is the square root of negative 3. That does not work here. So I got to be careful. So the first value I can pick, I'm going to pick 3. Now, although 3 is not a perfect square, when I plug it into my function to find its y value, 3 minus 3 equals the square root of 0, which is 0. So my first point is 3 comma 0, right here. And notice I'm shifting the x from 0, 0, that unit's 3 units away. Here's 1, 1, 4, 1 off the original, or 4, 2 off the original, and 9 here. So each of these x points are moving 3 units to the right. Okay, so now I'm going to actually plug in 4. I'm going to pick 4. Now 4 is a perfect square, but when I plug in 4 here, I get 4 minus 3, which is the square root of 1, which is 1. So my second point here is 4, 1. So look, if I go over 4, okay, and I go up 4, 1 is my next value, okay, right here, and notice it's 3 units away from this point. So the next one I'm going to pick is 7, okay, and notice when I plug 7 in here, 7 minus 3 is the square root of 4, which is 2. So my next point is 7, 2. And that's the last one I'm going to be able to plot there without staying off the graph. So notice how each of these points are 3 units to the right, so I can graph my function. Okay, so you can pick any x value. Just be very careful on what x values you pick. Okay, I can verify this graphically, and I can go ahead and hit y equals, and I'll clear this one off. I'll do the square root of x minus 3. Now I have the older addition here, so if you have the newer addition, it'll put the whole square root for you. So x minus 3, there we go, and I should see the parent function here, and my graph shifts 3 units right. There's my graph. Now when I state the domain here and the range, this time my domain changes, okay, because I affected the x value. The domain here is going to change. X has to be greater than or equal to, well, I have to make sure that whatever's underneath here is greater than 0. So x minus 3 has to be greater than or equal to 0. So x has to be greater than or equal to 3. And you can see that graphically my first point is right there. So x has to be greater than or equal to 3, or in interval notation 3 to infinity. The y values don't change. Notice how my lowest y value here, okay, is at the x-axis. So my y is going to be greater than or equal to 0, or in interval notation 0 to infinity. Okay, so stay tuned. We have one more video, and it's going to combine multiple steps here. So if you have any questions or comments on this, go ahead and type them below. We'll see you next time.